Our final session for the day, our presentation is entitled, How do AI different Building an Open Source Society with AI for Good? Thomas Wolfe is a co-founder and chief science officer with Hugging Face, where he's been at the inception of the open source educational and research efforts for many years. He enjoys creating open source software that makes complex research models and data sets widely available, and he is looking at LLM accessibility and the limitations of these models today. Ladies and gentlemen, please give a warm welcome to your final speaker of the evening, Thomas Wolfe.
Hi, everyone. So, almost exactly 1 year ago, we were preparing at Hugging Face for the UK Safety Summit that was happening in London on November 1st, where our chief policy people, Irene Soleiman, would talk about the dangers of AI and also of open source. And I think in the past year, not only politics, but everyone has been exploring very deeply the danger and the risks of AI. There have been countless headlines on the risk of deepfakes, of phishing. Would AI maybe be used to build, biological weapons or nuclear weapons or cyber attack at scale? Would AI maybe even free itself from its chains and decide to destroy humanity? And I think it was quite interesting to dive deep in this. And the discussion, according to me, was very fruitful. It brought some necessary regulation in EU AI that's currently being developed that I think we should have probably had earlier for things like social networks. But today I want to talk about something else. What if AI just work? What if actually AI work really well? And just like our other dual-use technology, just like the internet, computers, or smartphone, what if AI just becomes a tool that's so useful that it's integrated everywhere in our life? You know how today, if you land in a country and you don't have network, or if you come in a city and you can't access the internet, you know how you feel you stepped in kind of a different reality, a different dimension? A lot of things you usually do, you cannot do them anymore. You cannot order a taxi. You don't really know where you can go. You don't know how to select the restaurants you want to go in. You're a little bit bored because you can't scroll your feeds. You feel a little bit blind. You're missing an internet sense, which is kind of an extended sense we've built over the years because we co-adapted with these technologies. And this is what technology can do to us. And it can actually be even more drastic. So let me tell you a little bit about how, in the beginning of the 2000s, in the year 2000, a neuroscience research company, developed a breakthrough implant. Oh, I forgot about my slides, actually, because usually I don't have slides. But that was the headlines. And that's the question I'm exploring today, if you've been following well. Who followed well? No one? OK, a couple of hands. Yeah, good job. And that's what you feel. And this is scary, right, when you have that, and you don't really know if you're going to be able to get this SIM card or this thing to connect to the internet. And this is what I want to talk to you about now, which is what happened in the beginning of 2000, where a company, a research lab, developed a breakthrough retinal implants that was able to give back sight to blinded people. So they selected a couple of hundred patients, people who were basically born with a normal vision, but because of some kind of genetic disease, in particular one called retinitis pigmentosa, they progressively lost sight. And by the beginning of their teens or early adulthood, basically they were seeing less and less until they were in the dark. And when you think about it, this is maybe one of the most frightening things that can happen to you, right? You live in this sighted world, and then progressively you have less and less access to your vision until you cannot see anything. And then come these implants. And they worked really well. After 1 year, 80% of the patients reported a positive impact on their quality of life. It gave them not exactly vision, but kind of a different sense of vision that they could actually learn to co-adapt with and to use as vision. They could start to see again doors, windows, elevators. They could locate objects on a table. Basically, a lot of things we take for granted, but that becomes extremely difficult. Now, what happened a couple of years after, about 10 years after the first implants, is that unfortunately the companies went through some financial troubles because of the high cost of developing these implants and the difficulty to find the right product market fit given the size of the market. Basically, overnight, they went bankrupt. So all the knowledge, all the IP were closed, was private, right? The only people who really knew how these implants work were basically a couple of engineers in the now defunct startup. And so the people who were implanted basically went slowly back to the dark because the implants were not maintained. They became deprecated, in other words. And you may be wondering why I'm talking about that, because AI is not like a physical sense, right? AI is not like something that helps you see. But I think a lot of people underestimate the impact AI is going to have on our society in the mid to long term. I think sometimes it feels like, sorry, I moved too fast. Sometimes it feels like you're explaining to someone from the 90s, if some of people here are born this time, how our world today with smartphone and internet is. You explain them today, Gen Z in the US have 9 hours of screen time per day. This is something that's almost unbelievable if you live in the 90s. It seems alien because you cannot really project the life you live in this future life. That's actually just 10 years away, right? So I think the question is, will AI become one of these technologies that change our world so much that we co-adapt with it? And I think there is two types of technology. There is kind of what I call the nice-to-have technology, which is basically your GPS, maybe your music player, or your bank app on your smartphone. This is something, if it doesn't work, you can manage to deal without, right? GPS, you can still read street signs. That's what we did for a long time before we got GPS. With your music player, you have other ways to listen to music. It's not something that's really very problematic for you. And there is a second type, which is technology that becomes so deeply embedded in our world that we co-adapt with it. And I think there is a couple of things that make technology become like that. And these are things that are deeply related to our psychological drives, like laziness, fears, or hopes. For instance, laziness, that's something that technology is very good at helping us with. That's why we have cars around. That's why we all Google the knowledge that we were supposed to have, but that we don't really remember anymore. But hopes is something deeper, fears is something deeper, and is maybe more impactful, you know? The rise of social media, the rise of these endless feeds, this is driven by the fear of being alone, the fear of being bored, the fear of missing out something that we should have known about. And this is much more deeper, right? When technology reaches the stage where it can protect us from these fears, it has this very strong grip. And even deeper is the hope, what I call the hope to transcend ourselves, to become kind of a little bit like gods or superheroes, depending how you grew. And this is the thing that brought us technology where you can summon a car, you know, with just your finger on your smartphone and a car comes. This is the technology that makes you, if you speak in your house, you can actually now have the lights that starts. And this is something that's maybe even deeper than fear, this hope to transcend ourselves. And you have to understand that AI actually checks all these boxes. It's a technology that promises to offload the most work we've ever seen out of all the promises of technology revolution. It's a technology that promises you to have an AI friend that will be actually very smart and interesting and always available, that promises like photorealistic AI-generated content, constantly feed through you. So you will never be bored when you can have all this content all the time. And it's maybe the most godlike technology with AGI and this fantasy of creating something that's as close to life as possible. This idea that you can now just write, you know, a prompt and generate a world image of the world that's photorealistic. So this idea of generating life on world, this is the most godlike technology. So when you look at this, it's pretty obvious that in various ways, AI is going to permeate in our whole world. It's going to be a bit everywhere. And the question is, when it's everywhere, will we also risk losing this technology? Today, when we don't have access to the internet, we feel this void, right? Tomorrow, where we won't have access to AI agent or AI assistant that we take for granted, we also feel this emptiness, this powerless. We also feel a little bit lost. We don't really know how to do these things anymore. And you have to see this risk is already here. Because these AI models are very costly to build, because they're very costly to deploy, to maintain, most AI companies don't keep all these models alive. They phase them out. If you go to the website of the largest company today, or the most famous, right, OpenAI, you have a full page called deprecation that lists all the models that are not available anymore. And for at least one of these models, I remember Codex, there were enough people complaining about the deprecation that the CEO decided to overcome and say, OK, we're going to maintain a little bit this model. And this knowledge is also very private. When they deprecate a model, they don't just give it as free goods for everyone. It just disappear. So the question in the future is there a way we could avoid being trapped in the same problems, right? So to answer this, I need to go back a little bit to my personal story. So 15 years ago, I was a researcher in physics in a lab in Paris. And you have to understand that in physics, accessing knowledge is actually pretty hard. So most of publications are paid publications, and if you ever try to buy an article from the biggest one, for instance, Nature, you probably know it's not cheap, actually. Accessing knowledge is not so easy. For me, it was even harder, because I was working on cold temperature superconducting material, where most of the breakthrough fundamental research has been done by the Soviets between the 70s and the 90s. So I had to track down Russian articles in the Soviet GTP letters. That was really hard. And this kind of made me discover that being able to freely access knowledge is something that's really crucial if you want to build on top of what the others have been building. And when I moved to computer science later, I discovered this extension of open science called open source. Open source is not only about sharing knowledge, ideas, basically the theory behind what you've discovered, but it's also about sharing the engineering details on how to build the thing. So you're not only sharing the theory behind cold temperature or superconducting materials, but you also share the blueprints of the cryostat you built to cool down your materials and to use them. Open source is maybe one of the most impactful philosophical inventions in computer science. Today, it's used by 90% of Fortune 500 companies, and it's the reason small teams in computer science can build software that actually are resilient to even the creator's departure. And so that's what I propose for AI. What if AI just works and in the future is very useful? Then I would like to see a part of it using the lesson of open source. And these lessons are around transparency, mutualizing costs, but also this notion of resiliency. Let's picture this world in the future, right? We have AI a bit everywhere. It's not dangerous. It's actually just very useful, like most of our technological tools today. And instead of being all kind of closed box, basically owned by a couple of private companies in the US usually today, it's actually open. So a lot of them are transparent. Instead of running in the cloud, a lot of them actually run on your smartphone. They don't even need to send your data. They don't even need the network, actually. Because more and more, we can actually have very useful AI model just run on your smartphone. Now, you may be wondering if you've been following. Oh, I forgot my slides. Nah, anyway, you're following, right? You don't really need the slides. I made them for here quickly, so I don't really use them. This is just a fun picture of me when I was a researcher 15 years ago. Didn't have gray hair, so I keep it here. So, but if you follow very well what I said, you remember I started by talking about the danger and the risk. So you may be wondering, yeah, openness, this is nice, but what are the risks? And that's a good question. I think the answer we came to in this past year was that The openness axis is basically orthogonal to the benefits risk axis. With openness, you bring more people around the table, you give access to the technology to more actors, which basically intensify the activity in the field. Basically bring new effects, new use case in the field in a kind of a way that's roughly neutral to benefits risk, which means it will both increase the risk and the benefits. But as we discussed today, closed source systems are not the bulletproof solution. They have their own set of risks and benefits that we tend to ignore when we say this is just a line axis. So my hope is that in the future, where we'll have AI everywhere, AI that just works like the AI I'm trying to build, at least one part of this AI will be open, will be transparent, will be accessible, will be able to tweak it, to actually adapt it for use case, maybe even smaller use cases that are not sustainable economically. And I hope that when the AI revolution fully unfolds, then we'll be relying mostly on this open system for our own safety and resiliency. Thanks for staying until the end.
Thanks, Thomas. That was a great talk. Thank you. Questions from the floor for Thomas. Raise your hands, please. I want to ask, how important has open source machine learning models, how important has the fact that a lot of it's been open source been in getting us to where we are right now?
Essential. Essential. We tend to forget, because of the recent history, that ML and AI was traditionally an extremely open field. Like if you look at the Nobel Prize right now, George Hinton and the Turing Award, and all basically the creator of the field, Yann LeCun being maybe the most famous, these people have been all the time extremely strong proponents of open source. And the first widely used model, GPT-1 and BERT, and even GPT-2, were all open source. So this really gave all the stream for the field to start. And this kind of rise of closeness is very recent history in the field.
How do you feel about the fact that OpenAI went from open source to not so open?
That's their choice, not mine.
Okay. I was wondering how diplomatic you're going to be. The answer is super diplomatic. Yes, we have a gentleman here.
But maybe one thing important, and it's very interesting, is that we see recently, and I say recently, it's in the past few months, OpenAI going back to open sourcing many things. So they open source very interesting benchmark recently, a new version of their Whisper speech recognition system. So my hope is that they are progressively seeing the light again.
Yeah.
Yeah.
Okay. Yes, go ahead.
Well, thank you very much for your intervention. I'm a big sustainer of open source indeed. My question would be to you, we now, as you guys do, your open source all the models, but now the shift of attention is towards the type of data that this AI model use. And so the question to you would be, how open source data should be, and indeed concerning privacy and all those issues, and how you guys deal with it. Thank you.
Yeah, it's a good question.
Yeah.
And in general, open source cover many things. It's not, so there is a lot of debates if you follow on what is open source exactly. I think it's a full spectrum, which go from a very closed system. Actually, some systems are so closed that you don't even know they exist. You don't even have access to them. And then you have more open systems. You can use them with some APIs. Some systems are only open weights. You can have access to the weights, but you don't know how they train them. And even wider, or more open system, like the one we built a couple of years ago in Big Science, where we try to open also the data sets and maybe even the code and how we train them. So it's a full spectrum. I'm not saying everyone should be in the very strong extreme. That would be like, if you know in computer science, that would be like requiring everyone to have a GPL license, which is a very strong license that force all the derivative work to be open. But I think it's very interesting that people are a bit everywhere on this spectrum. And in particular, what you say about data, I think the more we could have access to the data, the more knowledgeable we would be about the models and how they will behave. So that's a very important part, I think.
Yeah, and there's certain domains where that data, if we got more access to that data, could be hugely beneficial. Health, for example, space exploration, physics, and so on. Do we have one more question for Thomas Wolff? Yes, this lady here. And this will be the last question of World Summit AI 2024. So congratulations.
Well, if I would have known this, I would have prepared the question much better. But thank you in any case. There's a big discussion at the time being, especially in America, about licensing AI, due to more security of the systems. And this has been pushed by a lot of political parties, but also, of course, a lot of companies who are quite interested in being the ones who can license it out to other ones. Can you imagine any kind, because you're, of course, totally for the open source way, is there something where you say, okay, this makes sense for these or these kinds of AI systems, that it's really strictly on a licensing basis, or do you say, in any case, open source is the better alternative?
You mean by licensing this idea that only some people should have a license to
Exactly.
train model? Yeah. I'm a bit doubtful about this idea. I don't say everything should be open source. I also think some models should not just not being developed for sure. Like there is some limits. I think for the models I was talking about, the small AI assistant that's going to be everywhere. I think open source is a quite natural solution. Open source smaller models, I think, can do a lot of very useful tasks, even if they can't invent the next nuclear weapon. But that's great, right? We don't need them. But if you are just asked for a summary of a text or like rephrasing something, you don't actually need a model that can solve the Riemann conjecture, right? So I think this idea that we don't really need one single model that solves everything, but we can have smaller models is very interesting. And for this, I don't think we should have any type of license. And then the other reason I'm a bit doubtful is how we see how people moved, and this company that seems very solid are actually very fluent with the, like a lot of leadership moving from OpenAI to new companies and Anthropic. So feels like closeness is also maybe not as stable and solid as we thought. Because these people who know how to build this model, go to create a new startup, they still know how to build a model in their new startup, right? So just attaching this to some entities feel like a little bit arbitrary and maybe not a great idea to me. Plus, I mean, the elephant in the room is obviously the question of regulatory capture. I think that's the main danger we have, which is making a regulatory process that's so complex that only a couple of companies with wide pocket, a lot of lawyers can actually participate. I think that would be a very sad outcome for AI. Yeah. That definitely would just, bring very strong concentration of power, and, for instance, Europe would have a lot of problem competing with new startups. So that's mostly what I think we should try to avoid with regulation, which is something that's so difficult to enter that we can solidify the current position where basically you have Microsoft, Google, and a couple of winners already there.
As you are the speaker closing out our main stage here at this wonderful conference, I want to ask you just one sentence on how you feel about the future when it comes to AI and what we're doing with it in society.
I feel very optimistic. Yeah.
I'm so glad you said that.
No, for many reasons. I think the good example, was just this week, this Nobel Prize in AI. So you may be for or against. I'm a former physicist, so it's very surprising for me that the Nobel Prize in physics come to AI. But that's really a testament, and in some way, it's I think, a good thing, a testament of the impact AI is going to have in all our society, and in particular on science. Didn't talk about that, but so many scientific breakthroughs are going to happen because of AI.
From Hugging Face, Thomas Wolff. Thanks so much, Thomas. That was awesome.